I know where to get some.
Yeah, I don't.
All right, subnetting. So we've all been through TCP/IP, and we learned what in TCP/IP? IP addresses, subnet mask, and classes. How to tell if it's class A, B, or C, and how to convert binary to decimal backwards and forwards and so on. So our outline for today will be, we're going to learn how to subnet a class C address. So first, since we've already been through TCP/IP and learned about IP classes, what is a, missing a couple letters there, a class C address, or a class C IP address? What does that mean? Can anybody tell me anything about a class C IP address that we learned in the previous class?
Medium companies.
It's for small companies, okay? So why would it be for a small company and not for like IBM?
Because it only has 250.
It only has 256 IP addresses, right? Which gives me only 254 available hosts. Whoa. Okay, that's the most important thing about a class C IP address, is that you can only have 254 computers or printers or cameras or whatever network devices or hosts in that single network, right? Now, there's a problem with that, and now the whole reason of subnetting, I guess before we actually get started, I kind of got to present a problem to you, is that the whole reason of subnetting is that back in the days, before the days of NAT, every computer in your home that was connected to the internet had its own IP address that identified it in the world. So if you were in your kitchen on the internet, that would have its own IP to the world than the computer in your living room. That would have its own IP to the world. So people could get to your computer, not to just to your house like today, but to your house and directly to the computer in your living room, or they would be able to identify it that far out. So if you had 5 computers in your home, that kind of presented a little bit of a problem. Not to you, but to everybody else. Let me explain why. Well, in this case, we've only got 3 computers and a router, so that's 4 total devices. Now, we're going to take this class C IP address, right? It's 201.1.1, and how do we know that this is a class C IP address? Because of 201, it's in the range of to 223. That's right. Because it's in that range, this number, we know that this is a class C IP address, which means it has a subnet mask of what? 0. Now, what does that 0 mean? This is the host, so this is all the network, right? This is network, and this is host. Now, what numbers can I put in this octet right here? 0 through 255, right? With the exception of 0 and 255, and let me explain why. 0 is the very first IP address in this range. The range is 0 through 255. And the very first IP in any range is known as the network ID, or it identifies you, or identifies your network in your world. So this network ID would be 201.1.1.0. This right here, you can't use it on your computers because it's for your identification for your whole network. Okay. Now the last one, does anybody know what the last one is? The 255. Well, do you know? Does anybody know why we can't use it as the 255? Because it's a broadcast IP, right? The broadcast IP number right here is not a real device in your network. It's 201.1.1.255. Okay, that's a 55. Trust me. Now, the way the computers kind of use your broadcast is, remember earlier in another lecture I was talking about IP communications like a freeway with a lot of lanes. And then we've got shoulders that you're not really supposed to drive on. Well, I would think of that as the shoulder. Anytime a computer has an issue, this is the lane that it goes to. So for instance, let's say that we have this router, and the router would be the very first device in your network, so the router would get an IP address. Usually it's the first one, 201.1.1.1. That is his IP address. That is him on that network. So then the very next computer turns on. And then he says, hey, I wake up, and then he says, I need to you get on it, you go to google.com. Well, first and foremost, he doesn't have an IP address. So he shouts out on the broadcast, I need an IP address, and he gets it, and he's like, well, I can't give it to you. And then he gets it, and he says, I can't give it to you. And he gets it over here, and he says, oh, I can give you an IP address. And, he starts a little table here, and he got his MAC address, whatever his MAC address was. And says, all right, I'm going to give you the IP address of 201.1.1. And he picks a random one that's not being used by these two or by himself or by any other computer. So the very next available one would be what? 2. So he says, you will be 2. So his MAC address is now known as 2. Or that's his IP address now. So he used that broadcast to kind of get an IP address because he didn't know who to ask it from. He didn't know where the router was. He didn't know what IP address the router had. So he threw it on the broadcast. And the broadcast is where everybody gets it. So, for instance, if this was a network here and somebody broadcasted something, they would just open the door, stick their head in and say, Chris, you got a call. Okay, and then we all heard it. We had to stop. We were writing, whatever we were doing. We all had to stop what we were doing. We all heard it. Chris, you got it? Okay, whatever. Then you keep working. Okay, you got it. It didn't concern you, so you just kind of dropped it and kept going with whatever you were doing. Chris would, or I guess one of the two Chris's would respond. Well, first he would say, which one? But Chris would respond and get up and go and take his call. Okay. So that's kind of how the broadcast is used by every computer if they ever have an issue. Now sometimes even the router will use it. For instance, if there's a message from the internet coming in and then the router gets in, he's like, I have a delivery for computer MAC address, whatever, or any kind of message or an IP address or anything. Maybe it's a static IP address. For static IP address number 3, but he didn't know who it was. So he doesn't have the MAC address. He just knows that there's a computer in his network for 3, but he didn't know who it was before this. So what he would do is he will throw it on the broadcast. He's like, are you 3? No, I'm not 3. So he keeps listening. Are you 3? And he says, yeah, I am 3, by the way. That was statically assigned by me. The user came in and opened up the control panel and the network connections, and he typed in this number. He says, I am 3. So he responds, this is my MAC address. So now that he has his MAC address, he applies the MAC address to 3, keeps up with his little routing table that he's kind of got going on right there. So then he knows that this guy is 201.1.1.3. So the router also uses the broadcast, if he ever doesn't know where to send it. All right. So any questions on how we use or why we can't use the first IP address or the last IP address? No? All right, so from this range, the range of 0 through 255, we said we can't use 0 through 255, so the very first one that we can use is 1, and what would be the very last one that we can use? 254. And that is how we went from a range of 256, sorry. So this is 256 total because 0 counts as the first one. So we went from 256, subtracted 2, and we got 254. Great math skills there. I'm off to a great start. Now, back to our original talk about the problem. Now, this isn't a problem for this network. I mean, he only has 3 computers and a router, a total of 4 IP addresses, right? So he's using 4. Let's do a little hard, trigonometry, math, whatever. We subtract 4 from that. How many extra IP addresses do we have down here? 250. So how many is he not using? So he's not using 250, which means he is wasting 250 because, Chris, this is your network. Okay, you'll be the wasteful today. So Chris had 2 computers and a laptop and a router, and he had to register a whole Class E IP address just for his 4 computers. And then Chris, part 2, wanted to register his network, but he's only got another 5. But he had to register a whole 254 computers or IP address range just for his 5 computers. And then you did too. And then, this just kept happening and everybody kept growing. And then the INA, remember the people who set up and broke apart the IP addresses, they said, well, this is kind of becoming a problem. I mean, now Daryl wants 250 computers, but he's really only using 5. And, He's not using all those 250 IP addresses. Let's just give a couple of his to him, and to you, and to you, and then all of y'all can just share that range. Okay? And essentially, that's the solution. That's the way that they came up with subnetting, and that's all subnetting is. When you take that big range and you just break it into little sections, per se. Now, the way I kind of give this lecture is I show you the problem, I show you the solution, then I show you how we got to that solution. So here's the solution, and here's the trick, and here's the one thing. If you can remember one thing, remember this. When you're subnetting a Class C IP address, you can only subnet, or you can only break it up into a certain amount of sizes. You can take those 256 IP addresses and break them up into 2 groups, into 4 groups, into 8 groups, into 16 groups, into 32 groups, and into 64 groups. And you cannot do anything beyond that. And if you can remember that, that will just ease your whole pain of subnetting. Now, and this is actually very simple math. So if I have 256 IP addresses, because that's 0 through 255, right? 0 through 255, that's 256 total. If I could take 256 total and only divide it into these categories, or into these groups, and I told you, hey Bertha, I have 256 IP addresses and I need to break them up into 9 groups. What would you tell me?
You have to divide it by another numbers.
Which one?
Oh, God.
Well, I need 9.
Okay, by 64?
By 60? Yeah. I need 9. You're going to tell me, I'm sorry, Jay. You have to break it into 16. There's no other option. And just not use the rest of them. Just use your first 9 and then leave the rest of them alone. Or you can tell it the other way. You can tell me, Jay, and not only am I going to break it up in 9 for you, I'm going to have some extras for you to grow all the way to 16. Okay? So if these are the only options, you kind of got to, whenever you're subnetting, you kind of got to figure out how far do I need to go. Okay, because you can't break it into 3 even groups. It's not possible. Okay. If I had this company here, so this is the companies. These are all the little branches in this company, and they have 1, 2, 3, 4, 5, 6, 7. They have 8 total groups here, right? They have 8 branch offices. How many would they split it up to? For right now, we're just going to assume 8. Okay. Later on, I'm going to say to forget that, but right now, we're just going to assume 8. Okay. So we're going to take 256, and we're going to divide it into 8 equal groups. Okay. So there's actually a very easy math formula that we can do to do that, right? Just take 256 and divide it by 8, and then you get your answer. What would be 32? The answer is 32, right? So the answer is 32. So that means that each one of these is going to get 32 IP addresses total, correct? Okay. So now what we're going to do, now that we know the number that we've got to give each one of these, we're going to take the 0 through 255 and divide it into 32 equal IP addresses. And the way we do that is that we always start with 0 and we go straight down. And we add the number. So 0 plus 32 is, 32 plus 32 is, 64 plus 32 is, 96 plus 32 is, 128. Okay, 128 plus 32 is 160. 160 plus 32 is 192. You know that one, right? 192 plus 32 is 224 plus 32 is 256. Now, whenever you hit 256, you've reached the end of the line. And you will always, always, always reach 256. You're guaranteed. Because you're giving an equal portion of numbers. So 256 is a number that you can't reach because 255 is the last available one, right? So this is where we end. So you reach 256, you stop, give yourself a pat in the back, you did your addition correctly. Okay. All right. Now that we've reached 256, we know that the last one is 255. So we'll go ahead and put that one there because that's the last available one. Now, what is 1 less than 32? 31. And 1 less than 64? 1 less than 96? 1 less than 128? Okay. 1 less than 160? 1 less than 192? 1 less than 224? And voila, we're done. We subnetted that easily. So what we did is we got 0 through 255 and we divided it into 8 equal groups and we found the range that each one of those are. Okay? So if you take 0 through 31, that's 32 total because 0 is the first one that counts. And 31 would be the last one. Although every network, whether it's a full network or a subnetwork, needs to subtract 2 IP addresses, correct? What are those 2 IP addresses? The first and last. What is the first one used for? For the ID, so I'm going to put it right here. So this is network 1 right here. They're going to take the first one. So the 0 would be the network ID, and then the last one would be the broadcast, right? So what the very first computer, device, router, whatever in the network would take the very first IP address in this range. And what would be the very first IP address in that range? 1. And then the next one would grab any IP address as long as it's in this range, 1 through 30. Because I can't use 0 and I can't use 31. So can this computer be 10? Can this computer be 60? No, because it's not in the range. But can it be 16? Yes. Can this computer here be 31? No, because that is the broadcast there. So can it be 30? Okay. All right, let's move on to the next group. This will be group number 2 over here. That would take the second range. So what would be his identification? 32. You didn't say 2, did you? No? Oh. So what would be his broadcast IP? 63, so we can't use the 2 there, 63. And then what IP addresses can I give them here? Chris, who would the router be? What would be his IP address? Well, say something. So we got this range right here, this group right there. Okay? And now we got 201.1.1.32. Okay? So that's this guy right here. Now, and I'll go ahead and write it all out because maybe I'm abbreviating and I shouldn't be. So his network ID is 201.1.1.32 because that's the very first one in that range. His broadcast is going to be 201.1.1.63 because that's the very last one in the range. So what IP address can he have if he is in this group right here? You know the answer? He can have any IP address between these two numbers. He don't have to be. He don't have to get the first IP address. He can be anything between 33 to 62. He can be 62. And I do know some people that make the router the last IP in their network. That's just the way they roll. You know? Does that make sense?
My mind is going back to the very first one that we did where I think he gave the very first one was...
The very first one went to the router?
Yeah.
Well, see, the very first one went to the network ID, and there's the ID right there. And the very last one went to the broadcast IP. So these two are not being used by any computers in the network. Okay? This is one computer. He is 62. This is another computer. He can be 61. This is another computer. He can be 33. This is another computer, he can be 45. Okay? But the 32 and the 63, they cannot be used by any of the computers in network subnetwork number 2. Okay? All right, so let's look at group number 3 right here. This is group number 3 now. So let's look at subgroup or subnetwork group number 3. And you can even call them cities if you want. You could call this one Dallas, okay? And this is the Dallas section. This one could be in New York. This one can be in
Omaha.
where?
Omaha.
No, I don't like Omaha. No, I'm just kidding. Okay, so this is group number 3, the city of your choice. Okay, we'll call it LA. You got to be more extravagant. Okay, like where would you rather party? Omaha. Okay. All right. So this could be LA. Group number 3. He needs 2 IP addresses that cannot be used by anybody: the ID and the broadcast. Okay. His ID or his identifier is going to be the first one, 64, and the last one's going to be 95. Okay. So these 2 are unused by anybody in network number 3. Now the router would get what IP address?
Anything that range, so maybe 65?
65, yeah, that's perfect. 65 would be the router. The next computer would be 66. Can this one be 80?
Yes, it's a little range.
Okay. Can it be 95?
No,
Why not?
that's the broadcast.
Because that's the broadcast IP, correct. Can it be 94? Sure, why not? At your heart's desire. All right, so let's go back to group number 4 here. So we went to, what's another city? Omaha, okay. Well,
Are you from Omaha?
Nope. Just first thing that popped into my head.
all right, so we went to the Omaha. Excuse all the dust. Just kidding. I'm just kidding. So what would be his ID, Chris?
28.
Whoa. No.
96.
96. You're in the wrong network there. 96 would be his ID. And what would be his broadcast? 127 would be his broadcast. And what would be the router's IP address?
97.
97. We can write it all out again if we want to. 201.1.1. What was it? 127? 127. Whoa, not 127.
97.
97. Sorry, I'm sorry.
Broke our network.
I did. It was a test. You passed. All right. So what about the first computer in the network? What would his IP address, or what could his IP address be? 98. Can this one be 120?
Yep.
Can this one be 128?
Nope.
Why not?
It's outside the front.
It's in the other network, right? That's in the totally wrong network. He would be an outsider in your network that nobody would want to play with. None of the other computers would want to talk to him.
Can't be 127 either.
Oh, he can't be 20. Can't be 127 because that's the broadcast. That's right. All right. Bertha? The next network. Maine. Okay, we're in Maine now. I don't know what that says.
There's only 3 people.
No, we have computers.
They don't need computers.
That would be 160 for the ID of the network,
Okay, his ID would be 160.
and the broadcast would be 191.
So we can't use 160 or 191. What would the router get?
150. I mean, 170.
170. Okay. Can this computer be 190? Can this computer be 180?
Yes.
Can this computer be 170?
No.
Why not?
Because I already have another computer with 170 the router.
Oh, you do? You caught that. I didn't even catch that. I didn't even see that the router was 170. So can it be 171? All right. So you get the picture, right? We've gotten broken down all the way to 8 networks. And out of these 8 networks, wherever they are, whether they're in the same building, wherever they're across town, whether they're across the world, you were able to save a lot more IP addresses. Now, are you still wasting IP addresses? Yeah, you're wasting quite a bit. You had 32 minus the 2 that you can't use, gives you a whopping 30. Okay. Out of those 30, how many are you actually using? You're using 4 because the router counts. So how many did you waste? Still wasteful, but would you rather waste 26 or would you rather waste 250? Okay. I'd rather waste none, but not really possible. So this is the solution. The solution was subnetting. The reason subnetting was created is because there were a lot of IP addresses that weren't being used and we were starting to run out of IP addresses. They're like, why do you need 250? You just got 4 computers. Why don't you all get together and y'all share it? Now, in order to create this, in order to get the computers to understand that, hey, by the way, computer, your range is only 224 to 255. There's nothing outside of that you can talk to locally. They had to create another addition to IP addresses, and they called it a subnet mask, or a variable length subnet mask. What that means is that, and this is insider notation here, it's a bit count, we'll talk about that in just a second. What it means that you had to tell the IP address that certain parts of the host were not going to be there, that you were only going to get a small section. Okay? And that's where the subnet mask comes in. And if you ever see CIDR notation like this, where it's a 27, okay, this 27 gives you all the answers. As soon as you see that 27, you know that this is going on. Okay, that you've got broken it into 8 groups and that there's 32 computers in each group, and you know which IP addresses are IDs and which IP addresses are broadcast. Okay, just by looking at that single number of 27. Do you see it? Just visualize it. 27 broken into 8. It's a little hard to see in it. So let's see how that 27 works. All that 27 means is the total subnet mask bits, or the total is ones. That's how many ones there are in the subnet mask. So first and foremost, we've got to break this number down into binary. Let's go ahead and look at it here, 201.1.1.0. So how do we get 201 in binary form? What's the closest number to 201 without going over? 192, which means we're going to use these 2 bits here. And then what's the next step? I know we have a subtraction person and an addition person. You're going to add what? 192 plus 16 gives me 6, 7, 8, 208. Did I go over? Yep, so I cannot use 16. Let's carry that 192 plus 8. What do I get? 200. Am I over? Nope. 200 carried over here plus 1 gives me, hooray. All right, so we've got our IP address, or our binary of 11001001. And then, does anybody know how to get 1 out of this chart right here? That's right, 000000001. 8. Now, Chris, you get the tough one. All right, you got to get 0 now. You know how to get 0? Yeah. Sometimes I say that, they're like, what? I don't want the tough one. All right, so there it is. I cleaned it up a little bit. 111001001 0001 All right, so we've broken this into binary form. This is the same thing as that. Now this 27, what did the 27 mean? How many? You've got all of those 8 things, and okay. That means that there are 27 ones in the subnet mask. And that's all it means. It doesn't mean that 27 belongs to a class C, that belongs to class A. All it means, the only thing it means is that there's 27 ones in the subnet mask, and that's it. It means nothing else. There's no hidden truth or beliefs behind it. It just means there's 27 ones in the subnet mask. He don't know what's going on top. So let's write them out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right? The only problem is that we're kind of missing some digits there, right? How many digits are we missing? 5. 1, 2, 3, 4, 5. Why are we missing 5 digits? Because it's an octet. That means there's supposed to be 8 digits in each one of these blocks. There's supposed to be a total of 32. So if this is 27, that's telling me that there's 5 zeros. That's one thing that I know, because there's supposed to be 32 total. Now, when you put the ones, and all we're doing here is we're setting up all the ones from left to right without skipping. And in a subnet mask, you can never skip a bit. You always have to go ones, and when the ones end, it goes zeros for the rest of the time. You can't go 0 and then a 1. Okay? The subnet mask does not work like the IP address. The subnet mask, it's all ones to one side, all zeros to the other. It's segregated. Okay? All right, now, what does this 201 mean? I'm sorry? It's the class C, right? And in a class C, there was 3 ways to identify a class C, right? 1, 2, 3. What was the third way? It was supposed to have this type of subnet mask. It's supposed to say 255.255.255.0. That's what a class C means. Right? You remember that from the last one? Okay. So that means that a class C has how many ones in the subnet mask? 24, right? 8, 16, 24. And there's supposed to be 8 zeros. So because of this 21 here, 201 here, and in subnetting, that's the most important thing. Whenever you look at the 201, I'm going to say everything's the most important thing. Whenever you see the 201 there, this 201 tells me that there were supposed to be 24 ones in there, and the rest of them are supposed to be zeros. They're supposed to be, right? Because that's what we learned in the last one. So that tells me that these 3 ones, 1, 2, 3, are oddballs. They're not supposed to be ones. They're supposed to be zeros, right? Yes. Yes. It's not a trick question. Not this time. It will be later, but not right now. All right. So let's go ahead and break this into actual numerical values. Do you know what 8 ones equal? 255. 8 ones equal? 8 ones equal? So what does 3 ones equal? 1, 1, 1, 0, 0, 0, 0, 0 equals 224. And there it is right there. Magic. My writing got really neat. Yeah. So this 27 told me that the subnet mask was this, because the 27 told me that there were 27 ones in the subnet mask. That make sense so far? Yes? Yes? Okay. All right. Now, we were talking about earlier that this 201 was telling me that this is supposed to be there, that is supposed to be there, and that is supposed to be there. You know, a class C always has 24 ones in it, in the subnet mask. Now, these extra ones are known as borrowed bits. They're also known as mask bits, subnet bits. You're going to hear them called a lot of things. They're oddballs. That's what they are. They're ones that are supposed to be zeros. And I guess before I continue, let me just tell you this. And the reason I put all the different terminologies in there is because there's more ways to subnets than you can count. There's tons of different ways to actually do this process. I'm going to show you how to do this long, complicated mathematical way, and then I'll show you how I do it. I don't do any math. I just use my fingers. That's it, right? So I have to show you the math behind it, because if you get the math, then you've got it. You're good as gold. Okay. If not, I'll show you my way, and then you're still good as gold. Actually, you're good as platinum if you know it my way. All right, so we've got these 3 ones that are oddballs. Okay, I call them X. Other people call them borrowed bits, X bits, and subnet bits. And the zeros, I call them Ys. So we have X and Ys, X bits and Y bits. Okay, I guess another cool term you could call them is N and H for network and host. It's up to you what you want to call them. But the thing is that these 3 ones are what's doing all the magic. That is what's breaking that subnet into 8 equal groups. Okay, those 3 ones right there. And there's 2 formulas that you can use to subnet anything. It's 2 to the power X and 2 to the power Y. 2 to the power X, and X being 1, 2, 3. So X equals 3, which means Y equals what? 5, because X plus Y will always equal 8. So if you knew that X was 2, what would Y be? If X was 2, what would Y be? 6. Because X plus Y equals 8. X plus Y is always 8.
Okay, I lost.
Okay, you lost me. All right. So let's go back here. Right now we're going to forget about all of these right here. Just forget about all of those because those are part of this 201. They belong to this guy. These 3 oddballs, or these 3 ones, we're going to call them X. If there was only 2 ones, X would equal 2. If there was 5 ones, X would equal 5. Okay? However many ones extras or how many ones oddballs you see there, they will be known as X. All the zeros will be known as Y. You got me so far? So, if I had 2 ones, X would equal 2. And Y would equal what? 5. Well, no, not 5. If X equals 2, how many zeros are there? 1, 2, 3, 4, 5, 6.
Are you turning that into?
Yeah, because remember, there always has to be 8 here, always. Okay, and it's probably throwing you off that I'm drawing on that. That's probably what's throwing you off. So I'll draw it over here separately. If I have this right here, X equals what?
4.
And Y equals?
4.
Okay. What if I only told you this? What if I only told you X equals
1.
and Y equals
0.
7? Why 7? Because there has to be 8. Because however many X are plus however many Y are, it has to equal 8 no matter what. Okay? So what if I told you there were 1, 2, 3, 4, 5, 6. There are 6 X's. How many Y's would there be?
2.
2. All right, you've got me. All right, so we know that X plus Y always equals 8, right? Right? Yes, good. All right, so in this scenario, in the form of 27 here, 27 means that X equals 3. And it's only because of this 201. If this 27 was on a 10, X and Y would be totally different. Okay? Now, in this scenario with 201, X equals 3 and Y equals 5 because they always have to equal 8. Right? Let me clean that up a little bit there. Okay, so we have 2 formulas, 2 to the power X, 2 to the power Y. Now go ahead and replace X with a 3 and Y with a 5. So 2 to the power 3. Now do you remember how to do your powers? You just write 2 that many times. So 1, 2, 3. So 2 times 2 is? 4 times 2 is? 8. So 2 to the power of 3 equals 8 subnets. How many groups did we have in the beginning of the scenario? In the beginning, remember when we split it all up into all the different companies in Maine and Hong Kong and Omaha? There were 8, correct? So this is how you get subnets. Subnets you get 2 to the power of X. That's how many subnets total you get. Okay? Now, 2 to the power of y is your block size. So let's do 2 to the power of y. 2 to the power of 5. 1, 2, 3, 4, 5. 2 times 2 is? 4 times 2 is? 8 times 2 is? 16 times 2 is? 32. So then 2 to the power of 5 equals 32. Now, when in the beginning of our scenario, we broke it off into 8 groups, and how many IP range, or how many were there in each group? 32. So this is how we got that 32. 2 to the power of y, 2 to the power of 5. Okay? That's how we got 32. Another way you can get 32, I read this, I've seen how to subnet many different ways until I came up with my own way. But I saw this one's kind of cool. If you always take 256 minus whatever your subnet mask number up here is, it gives you the same thing, it gives you 32. Like I said, there's tons of ways to do this. This was just an easy way for you to get a block number that fast. 256 minus whatever the subnet mask number is. All right, so I like that, so I just threw that in there for tips. All right, so now that we know that using this 27 on the subnet and the class C subnet, okay, when you see 201, just think C. Okay, don't really matter what the number is. It's going to be either A, B, or C up here. Depending on this, it depends how all of this works, because this negated these numbers right here. If this was 10, we would only negate these numbers right here, and then X would be a lot bigger, right? X would be 8, 16, 17, 18, 19. X would be 19, and Y would be 5. Yes?
256 minus the subnet mask?
Yes.
The subnet mask is 27.
No, 224.
Oh.
This is the CIDR notation. This is the bit count. Okay?
May I ask a question?
There's no such thing.
Where would you find the 27? I mean,
Well, this I gave you the answer. In a minute, we're going to talk about how to get these numbers. So first, I'm showing you kind of how it works. I gave you the CIDR of 27, and I'm trying to explain how it works, because if you know how it works, you know how to choose it. Because when you subnet, you decide the number. You decide what that number is going to be. Because I'm gonna come up to you. You're going to be working in the field, and I'm going to tell you, hey, great news, we're expanding. Okay, we used to have 1 store, but now we're going to have 5. And then you have to figure out what kind of subnet mask, how many groups are we going to have, how many in each group, and your subnet mask is going to dictate what your notation is. Okay? So first is, if you can just follow along with me, we'll learn how we will choose these numbers. In this scenario, I chose this number for you, because I gave you the solution. Remember, I gave you the answer. I gave you the answer so that you can see how these numbers go back to that answer that I gave you. All right, so now that we have our 2 to the power 3 and 2 to the power y, and that we know that using this 27, that we're going to have 8 subnets, and each one of those subnets are going to have 32 IP addresses in it. Now we can take the range, and the range is going to be this right here, because once again, in a class C, we cannot mess with these guys right here. That will come in supernetting. That's way later. Okay? In a class C, the first 3 octets are written in stoned, because these are the network, and then this one is the host. So now we will take this range and break it off into 8 equal groups, and each group will have 32 IP addresses in it. And that range was 0 through 255. So we're going to do that exactly like we did it in the beginning. We're going to start with the 1 column here. We're going to start with 0. In this case, we'll write it all out. 201.1.1.0. And then we're going to take our block size here. And then you'll hear me say this all the time because it's easy to remember. Whenever you find your block size, you do 2 things to it. First, you will make it into a button. There's our button. Right under that, we're going to put 0. And then right under that, we're going to put the same number, whatever that number is. 32. Okay, so we did 2 things. As soon as we found our block size, we did 2 things to it. We made it into a button, an addition button, and then we put it right under 32. I mean, right under 0. 0, then 32. So if this number was 64, it would be 64 is our button, 0, and then 64 under that. Okay? If this number was 128, we'd do the same thing. 0, then 128 right under it. All right, so now that we've kind of got it started, we can keep going. So 0 plus the button gave me 32. 32 plus the button gave me 64 plus the button gave me 96 plus the button gave me yeah. You threw me off with 1028. Oh, I heard 1028. 128 plus 32 gives me 160 plus the button gives me 192 plus the button gives me, and I'm done. Oh, 224 plus the button gives me 256, and when I reach 256, what do? Good job. I did it right. Okay, or in this case, good job. All right, so you stop because you reach 256 and you can't go beyond that. All right, so now filling in the last one, the broadcast. We know that 255 is the last available one, so we'll write that over here. 255. And now let's go back to the beginning. What is 1 less than 32? 31, so he would be 201.1.1.31. And then 1 less than 64? 1 less than 96? 1 less than 128? 1 less than 160? 1 less than 192? 1 less than 224? Okay, and you can go in there and fill in the 201.1.1 and all of these IP addresses. Now that we've got our network IDs and our broadcast IPs, and I always recommend you, and unless you're really good later on, never go left, right, left, right, left, right. Always go 1 and do all of these until you reach 256. That is the easiest way to keep yourself from getting confused going backwards and forwards. So always do the network IDs first. That is number 1 to do. Then you do all the broadcast IPs. That is number 2 to do. And then you can go back and do 3 and 4. Okay? All right, so, whoa, that's the answer. All right, so now we're going to go one IP address this way, which is what? 201.1.1.1. That is the very next IP address after 0. And now we're going to go one IP address this way, which is what? 201.1.1.30, because that is 1 less than that guy. So now this right here, this group right here, is known as our available IP addresses. This is what we can use. This is the range, but the range minus 2 gives us our available. Okay. All right, so then if we want to, we can go ahead and fill in the rest. What is 1 more than 32? And then 1 more than 64. If you notice, I'll always go columns down. I'll never go left, right, because you'll get yourself confused real easy. 97, 129, 161, 193, 225. And now this way, 62, 94, 126, 158, 190, 222, 254. Okay, I'll clean that up. Looks like that. Any questions so far? Sort of? Yes? No? All right, so if you ever wanted to know how many hosts or how many computers will I have in my network, you always take your block size and you subtract 2 from it. Now why are we subtracting 2 again? For the ID and for the broadcast. Okay? All right. So, any questions? No? I know it's quite a bit. And then, once you've got your groups like this, then you can actually start applying them like we did earlier. The first group gets the first range, the second group is the second range, the third group gets the third range, and so on and so forth and so forth. Okay? And then we just took this range of 0 through 255, we used this subnet mask, or this CIDR notation, whichever one you want to count, because they mean the same thing. And then we divided this group into 8 equal portions, and each portion had 32 IP blocks, or 32 range in each one. Out of those 32, we subtracted 2, and each group will have 30 available IP addresses. Now, luckily, this is being recorded, because I know it's a lot of information to take in 1 hour. But here's more. So, 2 to the power of x gave me 8 subnets, right? And then 2 to the power of y gave me 32 range in each subnet. Now, my block size minus 2 gave me my total host. That's how many computers I can have in that network. Now, there's only an issue with these formulas, or these numbers here, is the 0 and all ones subnets. Okay? The very first subnet, the very first group here, is known as the 0 subnet, the subnet 0, which means you really can't use it. Okay? And in all of our tech labs, they're written in a way where you cannot account for the first subnet, because it's the 0 subnet. And then the last subnet is known as the all ones subnet. That's actually their technical name. The all ones subnet is the very last group, okay, that you cannot use. So if we were to subnet this, we really wouldn't have 8 groups. We would have 6, because it would be 8 minus 2. Okay, so it really wouldn't work. And this is when I said in the beginning that for right now we're going to choose 8, but in reality we'd have to go up to 16, because 8 doesn't work. Because 8 only gives me 16 available groups. That make sense? Okay. So not only are you losing the first IP address in every group and the last IP address in every group, you're also losing the first group entirely and the last group entirely. So here's your formulas.
What is the reason why you can't do this?
I didn't make that up. That's the way it is. You just can't use it. Like, you just can't use the first one and the last one. Can't use the first subnet or the last subnet. Now, later on when you get to Cisco and some of the other stuff, you can use it in your your devices, and the actual devices that are doing the subnetting and the routing and stuff. Okay.
Is there any reason why you can't use them?
I don't know the reason, to tell you the truth. It's not been very clear in anything. It just for
That's the way they did it when they first started.
yeah, that's just the way it is. You know, it's the first one's kind of, I guess, the identifier of the whole thing. Like later on, we'll go into supernetting, which you subnet backwards, which is kind of a weird deal. That's when you take a class C and you make it into A or B or so on. But when you get to that, it kind of makes sense, because when you get all these subnets, they need a way for them to talk to each other. And that 0 out is kind of the way that they all talk to each other.
So if you cannot use these ones, what do you use for broadcast?
What do you mean? Each subnet has its own broadcast. This is the broadcast for this subnet of number 4.
You're telling me you cannot use
Each
them.
range has its own broadcast.
No, you can't use 1, and you can't use 8. But you can use everything else in the middle. You can use any of these numbers that do not have a red line on them.
Yeah, but those on the broadcast have a red line.
Well, it's in this group. It's in the group of 4, but no computer can have that IP address.
So you use a different number for a broadcast?
No, that is your broadcast.
Oh,
Okay,
that's the reason you can't use it.
that's the reason you cannot use it, because your broadcast, yes. So you can't use the first group, and you can't use the last group. And inside of each group, no computer or device can have the very first or the very last in its range. Okay. Now you got to be careful with that because sometimes the tech labs might read the range, and most of the time it'll say the available range. And if you got that word available in there, you've got to account for the top, the last, sides, and the sides. Okay. Which are not available. So the very first computer in any of these subnets would have what IP address? 33, correct. And the very last one would have. So now, you know that this is the only ones that they can be used. So if you had, and I'll show you in a minute the reason we go through this. But in a minute, let me come back to this because it might make more sense when I explain it then. Now, so there's your two formulas. This one will find your, or two sets of formulas. This will find your subnets, and this one will find your availables, the ones that you can use. Okay? They're also known as the standard. So while you're doing your tech labs here at the school, if you see using the standard method of subnetting, they're talking about the availables. Okay? What's available? And let me see, do I have my other, let's go back this way. Okay? Right here. So the reason we talk about with the availables is if I had, what was my block 32? If I had something like this going on, let me think. So I would have, this computer here has an IP address of 201.1.1.126, okay? And this computer over here has an IP address of 201.1.1.2. Oh, that's too many ones. Is it 201.1.1. 230, and they both have a CIDR notation of 27. Now this is kind of like what you'll see in the math problem. I mean the problems in our curriculum and on the certification. So you'll have something like this, and they're saying that they cannot talk to each other. There's an issue there, right? And then you'll have some multiple choice down here: A, B, C, D. And then the first one might say, it will say, there's no communication. What can you do to fix it? A will say, change computer. Well, that's hard to see there. There's A and there's B. That looks like the Blair Witch over there. Change computer B to 201.1.1.127. Change computer B to 201.1.1.208. Change computer B to 201.1.1. 201.1.1. So many ones. 206. Right? 126. Yeah. 120. That's 126, 127, 128, 206. And then change computer B to 201.1.1.2. Now let's do 69. No, that's not going to work. To 100. We'll do that. All right, so you're going to look at this. You can get your answers. And then you're going to have to subnet this thing all the way out and figure out what's the correct answer.
D.
I'm sorry? Why D?
This is on the same range of the same network.
Okay. So let's go one by one. Would 126 be able to talk to 127?
Well, 126 is
But it's one IP address away. Why can't it talk to it?
This is part of the other. It's
Don't yell at me.
a broadcast.
It's right here. You mean it can't talk to one IP address away?
That's a broadcast.
No, it can't. Correct, because it's a broadcast. So, okay, so can it talk to 208? So we know that's not the right answer. So is 208 the right answer? It's is not even the same range. It's in a totally different range, plus it's the ID of the other range. So that wouldn't even work. Okay? So then would 206 be the answer? Yeah, it's in this next range right here, and it's like it's not even near close to the correct range. So then, oh, I went the wrong way. So then, that's not it. So would 100 work? 100 is right there. So yeah, 100 is in the same range as 126. So now, this kind of gave you an idea of what kind of questions you will get as far as subnetting. So you notice that the little question was very simple. They gave you an IP address and they gave you a CIDR there. They gave you an IP address and they gave you a CIDR. And you had to do all this subnetting in the background and break it all down and figure out the groups just so that you can see what computer is in that range that is what's an available answer. Right? So that's the reason that you have to be careful with what's available, because and when you see this, if you didn't know how to subnet, you would look at this and you're like, well, this is 126. Well, obviously you can probably talk to 127. It's a one away. It's like kicking a rock over, right? But in reality, no, it's the broadcast. You can't use it. Well, 208 is, right next to it too. Well, they can't talk to that either. You have to make sure it's in the range and it's available. Okay? So does that answer your question about the broadcast and so on? Sort of, yes? Okay. All right. So we talked about our formulas here, the subnets versus the available ones. These are the ones that you can actually use. And do we have any questions on how the subnetting process works? It's kind of a loaded question, isn't it? Yes, no? We feel ready to move on to the second half?
That's when you set up the IP address manually, right?
Not necessarily. It's well, yes and no. You won't have to go to every computer and set this up. What you could do is go to the router and tell the router, hey router, by the way, you're 65 and you are in a, it's not down here, you are in a subnet mask of 27, and the router is going to know, oh, if this is me and my CIDR notation is 27, that means that we've got this going on and I can only use these guys right here. So the router knows all that by you putting that information there. Or you don't, instead of giving the 27, you can tell him you're 255.255.255.224, and then he knows everything else. And so should you. If you see that you've got one of these little markings down here, you should be able to how to break that all down using the formulas. Okay, if they gave you a 25, you should be able to use the two formulas and break it all down. If they gave you a 28, you should be able to break it all down into formulas, and so on. Now let's talk about those. Let's go ahead and move on. If we feel we can move on. Let's go ahead and talk about all the different options that we can do. Because I gave you a little bit of an answer earlier that you can only subnet into certain categories. There's no way you can subnet outside of those categories. Which were what? Do you remember? 2, 4, 8, 16, 32, and 64. Those are the only things you can do with a Class C. You can't do anything outside of that unless you go to supernetting. But once again, that's out of our range so far. Now, I'm going to try to explain subnetting in a easy way. Try to. So, when we're subnetting here, this is a Class C address, right? We've got this 201 that tells us this is a Class C. And in a Class C, we've got 8, 16, 24 ones that belong to that 201. Okay? Any Class C, doesn't matter what it is. As long as it's in the range of a Class C, these 24 ones belong to him. There's nothing we can do to them. Now, these guys over here, they're supposed to be zeros. That's what they are supposed to be because of that 201. All right, you with me? Now, when we subnet, when we choose how to subnet or how we're going to subnet, the only way to subnet is to borrow zeros and convert them into ones. The only trick is, and this is the most confusing thing, is that you can start borrowing from left to right only. You can't start borrowing on this end. You have to start here, and you have to go that way. And you have to borrow bits, and when you stop borrowing bits, the rest of them have to be zeros. Okay? So in other words, you can borrow 1 bit. You can borrow 2 bits. You can borrow 3 bits. You know what's next? Boy, we can count today. And then, whoa. And then finally, now here's the deal. You cannot borrow more than 6. And in a minute you'll see why. But just take my word for it now. You have to have at least 2 zeros. You can't leave 1 0 back there. Okay, he'll be too lonely. We come in pairs. All right, so we can either borrow 1 bit, we can borrow 2 bits, we can borrow 3 bits, we can borrow 4 bits, we can borrow 5 bits, or we can borrow 6 bits in a Class C address. And that's it. We can't do anything else beyond that. We can't borrow half a bit. You know, we have to borrow 1 bit at a time, left to right, without skipping a beat. So you couldn't borrow 1 and then 0, then 1 and 0, 1, 1, you know, so on. It had to be 1s until they stop, and then 0s from then on. All right, so our options is borrowing 1 bit, 2 bits, 3 bits, 4 bits, 5 bits, or 6 bits. So there's only those options there. Now, if we actually come back and look at that and see how that works, let's pretend that we're only going to borrow 1 bit, okay? We're going to borrow 1 bit right here. Okay, so our binary is going to look like this. One thing you will find out about me is that I am very color coordinated. I will stop the lecture and fix it if it's the wrong color. So we're going to borrow 1 bit there. So here we are. There's our binary numbers there. So now, do you remember our 2 formulas? Too much information overload. What's that? 2 to the power x. And what did 2 to the power x show you?
That gives you the
Subnets, correct. So here's our subnets. Our subnets are going to be 2 to the power of x. Do you remember the other formula? 2 to the power of y. And what did 2 to the power of y give you? 2 to the power of y gives you the range, or the group, or the increment number, or the block. You hear it called many things, but it's the range. All right, so there's our 2 formulas. Now, what was x, Bertha? X equals? We went over this. What?
1.
X equals 1. Score. All right, so 2 to the power of x. So 2 times itself, or nothing, would be 2. Okay, so 2 one time is 2. So how many subnets will we have if we borrowed just 1 bit? 2. Now, how big would our range be? 2 to the power of y. Y equals what? Y equals 7. 1, 2, 3, 4, 5, 6, 7. I'm going to show you a quick trick here, okay? 2 to the power of 1, 2, 3, 4, 5, 6, 7. Okay? So it's 128. So what is 128? That is our block, our increment, right? Our range. Now, do you remember what you did with that increment number? You made it into an add-in button, you put a 0 underneath it, then you put that number again, and then you keep subnetting from there. Okay? So this is the button area. This is where we create our button. And we'll come back to that in a little bit. All right, so remember, we're still talking about just borrowing 1 bit. If we borrow 1 bit, we're going to have 2 subnets, and we're going to have a range, or a block, of 128 in each subnet. Okay? By the way, what's 128 times 2? 256. Magical number. We just keep it up here in the cloud. All right. So in the cloud where everything else lives. All right, so there's a couple ways we could find the rest of this. Now, Chris, I'm going to let you pick the first one. Do you want to find the CIDR, the subnet, or the valid host? CIDR. Okay, we'll start with the CIDR. Now, here's one thing. We're talking about a class C, right? And in a class C, there's already 24. And oops, that was my goof. I have to fix something. So we're talking about a class C, and a class C already has 24. So we'll put a regular standard class C, no subnetting, in the top bar here. So in a class C, there was already 24. And the zeros look like this: 1, 2, 3, 4, 5, 6, 7, 8. And there was just one big group, or one big giant subnet. It was just a big group of 0 through 255, which gave me a total of 256, right? And out of those 256, how many can I use? Because it was 256 minus 2, that would give me that. So what I would do is actually I'll put the minus 2 right up here. So range minus 2 gives me my valid. That's how many computers I can have in that network. And my subnet mask was 0, because it was 255.255.255.0. Okay? 255.255.255. What is this right here? Subnet mask. What? So now, back to our CIDR question. So if a class C has 24 and we borrowed 1, what is 24 plus 1? You got the tough one, bud. Let me tell you. So if we borrow 1 bit from a class C network, the CIDR becomes 25. Okay? Because we're just borrowing 1 bit. All right. So now that we have our 1, 0, 0, 0, 0, let's go ahead and move on. Bertha, which one would you like to do? Would you like to do a subnet mask or the valid host? Subnet mask. All right. So to find the subnet mask, you've got to convert this number back into a decimal format. So what is 1, 0, 0, 0, 0, 0, 0, 0? 128. Okay, now remember that was the very first thing we learned, how to convert binary to decimal. So our subnet mask would be 128. Okay? Now whenever we find this, we're just going to go straight up to this bar. Whenever we have the ones, we find the last one and we go straight up to this bar right here. Okay? All right. So, Chris, you've got the next one, bud. You've got to find your valid host for borrowing 1 bit.
126.
126. And you got that how?
2y minus 2.
2 to the power of y minus 2. So 128 minus 2 gave me 126. All right? So that took care of... Ooh, where did I leave it? I lost it. There it is. So that took care of this whole column right here. We borrowed 1 bit and we saw what it would equal if we just borrowed 1 bit. If we borrowed 1 bit, we have a CIDR of 25, a subnet mask of 255.255.255.128. We're going to have 2 equal subnets, and in each subnet we're going to have 128 range, but out of those 128 we can only use 126. So we'll have 126 computers here and 126 computers there, and that's all the subnetting there was. Yes?
So under standard notation, you got to get rid of those 2.
You got to get rid of those
Right?
2. Yes.
So you'd never have that with standard.
No, not with standard, no. So you have to get rid of the top one and the bottom one. That leaves you with nothing. All right. So let's borrow now 2 bits. So we borrowed 1 bit. Let's go ahead and borrow 2 bits now. All right. So if we borrow 2 bits, how many? Let's start with the CIDR. How many would the CIDR count be? 26. That's the tough math. I gave you the tough one, bud. Okay. And then somebody else. What would be the subnet mask? 192. That's right. When we looked at the subnet mask, we're going to look in this bar right up there. So it looked like this because we're just borrowing 2 bits. So we just jumped straight to there. Okay. So our 92. You can also just do 128 plus 64. That will also give you 192. All right. Now, how many subnets or how many groups would I have? 4? How did you get 4? Because you're borrowing 2. 2 to the power 2. 2 times 2 is 4. Okay. And my range would be 2 to the power of what? 6. So 2 to the power of 1, 2, 3, 4, 5, 6, 64. Okay. And then how many valid hosts would I have? What was that? 62. All right. Now this next one should be easy, and this is the one we did, and I'll go ahead and fill it out for you. We did 27, which had a subnet mask of 224, which had 8 equal subnets, and it gave us a range of 32, but we could only use 30 in each subnet, and we borrowed 3 bits. Okay, so that's the one we did together in the beginning. So I filled that out for you. Now, by now, usually, you can start seeing a pattern. Do you see a pattern anywhere? Do you see a pattern anywhere? At least one? The subnets? Right here? What do you see? It's doubling up, right? 2, 4, 8. So what do you think is next? And then? And then? Okay, and remember you could only break off into these equal subnets. Now why could you only break off into these equal subnets? Because you can only borrow so many bits at a time. You can only borrow 1 bit at a time from left to right. Which gave us 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 1, 2, 3, 4. Well, will give us these options. These are the only options we've got in a Class C network. So now, do you see any patterns, Bertha?
Yeah, the numbers,
the CIDR, okay. What would be the next one? Or what is it doing? Just increasing by 1. 24, 25, 26, 27. Whoa. 28. And 30. Now, why can't we go to 31 to 32? Because I can't borrow those 2 extra bits, right? Okay. All right. So, any other patterns? Chris? A range? What is it? Is going down by half, by half, by half. So, what would be the next one? And then?
8.
And then 4. All right. Chris? Subnet mask. There's no pattern there.
Sure, keep adding 32, 16, 84.
Here's your pattern right here. $128, $192, $224. Guess what's next? And then? And then? All right. So $224, $240, $248, $252. Now this is the hardest pattern to see, but as soon as you see that one, you start doing it with your fingers. Okay? All right. So the last one, is there a pattern there? Yes, no, Daryl? It's just 2 less than that. Not really a pattern, but it's an easy way to find it. So 16 minus 2 would be, 8 minus 2 would be, 4 minus 2 would be 2. Which brings us to the grand conclusion of we cannot borrow more than the last 2 bits because we need at least 2 computers in a network. A network is 2 or more computers. That is the literal definition of a network. 2 or more devices communicating with each other locally. So if we only had 1 device communicating with itself locally, would that be a network? No, which would kind of make all this useless. So because we have to have at least 2 computers in a network, that is the maximum we can subnet out to 30, unless you do something special. Once again, supernetting, not done right now. So because of that grand number 2 down there, that is the max that we can go. And if I clean that up for you, it looks like this. Okay? So now this chart here shows you your only available possibilities for a Class C network. Okay? Now if you see this, you're starting to see patterns. You're starting to realize certain things that, or hopefully, that there's only certain options you can do. If I told you, Bertha, I need to have a network of a Class C divided into 10 buildings, what would you tell me? So I need 10 buildings. That is my requirement. I need 10 subnets. Or I need 10 buildings, I need 10 groups. What would you tell me? besides call Jay. You would tell me, whoa, Jay. Well, you would call me and then I'll say, hey, Bertha, you've got this. I would ask, Bertha, can they do 10 subnets?
Yeah.
They can? How many bits would they have to borrow to get 10 subnets?
Oh, yeah.
No?
So they can only do 6.
How many can they do? This is the closest number to 10 without being too out of the way. Okay? So you, Bertha, would say, well, you can't do 10 even, but you can do 16, which will give you 14 available, right? So you get your 10 plus 4 extra to grow. That's what you tell your boss. Like, I'm going to give you 4 extra to grow. That way we're ready for when we start opening new branches. Okay? So even though my requirement was 10, you're going to have to go all the way to 16 because there's no way I can get only 10 subnets. Okay? Now, if we do go to 16, I would say, well, Bertha, I've got this IP address of 200. Well, I guess I can't do 200. I've got this IP address of I had a brain fart. 102 to 223, right? I guess I could do 200. 200.11.12.0. Okay? And that has to be a 0 because in a Class C address, this last one is the host. And I say, well, Bertha, we've got 0 through 255 to work with. How can I split those 0 to 255 into my 10 buildings? What would you say, Bertha? Subnetting, okay, good. And then what kind of subnet mask would I need for this IP address here in order for me to subnet it into 10 buildings? This is where the magic happens, okay? Little fireworks popping out, okay? I would have a subnet mask of 255.255.255. What? 240. So my subnet mask would be 255.255.255.240. Or my CIDR notation could be what? 28. Okay. And if my CIDR notation is 28, remember my computer knows everything as soon as I give it either the subnet mask or the CIDR notation, because they mean the same thing. So as soon as I gave my computer the 208, what's the computer going to know? How many groups are there total? 16. And how many of those 16 can I use? And inside of each one of those 14, now I'm your boss again. Like, Bertha, okay, so you told me we have to split this up into 14 subnets, but how many computers can I put in each one of these subnets? What is the maximum number of computers I can have? 12. Not 12. 12 isn't on the board up there. 14. And how'd you get 14? Because it's -2 of our block, and this is our block, and it's in our valid host. You just say, oh, I looked at my chart and my chart told me so. Okay, that's a valid answer, as long as you made the chart. So, you notice how once we got any piece of information, if I told you I needed 10 subnets, you knew everything. You knew what kind of subnet mask I would have. You would know how many total subnets I would have and how many computers inside of each one of those subnets I would have. Okay? Using this chart. Now, you can do that exact same thing. Oh, where'd it go? There it is. I wrote all over it. Using my method. All right, so this is how I subnet. I use this chart, and do we have this in your notes that I gave you? I use this chart to subnet, and I use this chart to subnet a Class A, B, or C network. If the math is too much and it's just a lot to try to remember, then just try to remember it this way, because this way there's no math. If you're subnetting a Class C address, you have to visualize a couple of things. Once you get past that point, it gets pretty simple. You have to visualize that there's already 24 ones, and then just visualize that chart at that back end with 8 bits. Okay? So I've got 0 through 255 here that I've got to subnet. And you can give me any piece of information, and I can subnet it using this chart. And the only other two things I've got to finish visualizing is the number of subnets, which are what? How many available, or or what can I break into? You told me earlier. What was that? How many numbers I can break into? So these are the subnets that I can get. I can't get anything else beyond these numbers. These are the max or the minimum or whatever you want to call them of subnets that I can possibly get. I'm going to write them smaller. Okay. All right. Now, the last thing I've got to finish visualizing is my number of hosts. And now my number of hosts, I always just use the block size. The block size minus 2 is the available, right? So your host will always start with the back end, and it would be, I would just use these numbers here. It will go 4, 8, 16, and it's kind of a 32, 64, and then 128. And then this, when you see it here, it's kind of redundant. You're like, well, you have those numbers up there, Jay. Why do you have them here? It's because when we get to class A and B, it makes a lot of sense to remember those numbers down there. So just remember, it's this number minus 2 would give me my total host. So I've got those numbers. Now subnets always start from left to right with the very first bit that I can possibly borrow. And my host will always be the same no matter what kind of class I'm using. Not using the last 2 bits, I will start from there this way, and it'll always be right to left. Okay? All right, now, the way I have it here is the exact chart that we had earlier. That chart that we were looking at earlier that you gave me all the answers, it's right here. It's in this picture. For instance, if I told you the same problem that I gave you earlier, I would say, Bertha, I have 10 buildings, or I need 10 subnets. I would go, okay, well, you need 10 subnets, but you will have to go 2, 4, 8. You will have to go to 16 subnets. So I will have to go to 16 subnets. And how many hosts am I going to have in those 16 subnets? 16 minus 2 would give me my host. What is my block, or my increment number? And that's found in this range right here. My block is 16. And what is my subnet mask? Well, my subnet mask is 255.255.255.240. So then once you get that, you can actually start subnetting with your block. Your block is probably the most important one because that's the one you convert into your button. So you get your button. You put a 0 underneath, and then you put the same number that you had in your button. And then you just keep going from there. So 16 plus 16 would be 32 plus 16 would be 48 plus 16 would be, what was that? All right, we'll stop there. We'll keep going all the way till we get to 16. But then you can fill out your ranges, which would be one number before 16 would be, one number before 32 would be, one number before 48 would be, one number before 64 would be, and what is 63 plus 16? 79. So there's our ranges. This would be my first range, second range, third range, fourth range, and fifth range. Can I use my first range? So my first computer would have the IP address of what? Was that? 17, because I can't use my network IDs or my broadcast. Remember? So my very first computer would have 17 on it. All right? Let's look at one that's a bit smaller than this, okay? All right. So, Mr. Gadenda, I have my same chart, and I need to split it up into 3 subnets. Okay. Well, now we got to think in real life scenarios, okay? If I have a requirement of 3 buildings, and when you read this, somewhere in there you heard the word standard or something along that way. What do I have to remember? The subnets minus 2, because we can't use the first one and we can't use the last one. Remember? Yes? No? No?
Standard is the rule.
That's right. The standard is the rule that we cannot use the first group or the last group. So if we only have 4 groups and we can't use the first one and the last, how many are we left over with? 2. Right? So with 2, it won't fulfill my 3. So we go with 8. Now, as soon as I find my answer, I go here and I circle all that. And there's all my answers. First, how many subnets would I have available? I have 8 total, but how many available? So there's my 8. I already know I'm not going to use 1 and I'm not going to use 8, but I have 6 available. All right, so as soon as you find your subnets, I want you to always, as soon as you find your subnets, find your block, and whatever your block is, do your button and start subnetting it out. Okay? So what's our block in this situation? 32. That's right. The blocks are always right there. So what do I do with the 32? Make a button, 0 there, 32 there. Okay? So 32 plus 32 would be? 64 plus 32 would be? 96 plus 32 would be? 128 plus 32 would be? 160 plus 32 would be? 192 plus 32 would be? 224. So now let's fill in our back ends. 0 through what? 32 through what? 64 through what? 96 through what? 128 through what? 160 through? And 192 through? And 223 to? 5. Remember, there's nothing else beyond 255. That's the last one. So now that we've got our groups here, okay, we've got group 1 and group 8 that we're not going to use. The rest of the groups we can use, except for we can't use the first one, and we can use the last one. So one thing you'll commonly see, and you see this across everywhere, there's always a -2. Okay? And if it wasn't for that -2, this would be the easiest thing in the world because it's all patterns. It's all doubles and doubles and doubles and doubles. And as soon as you start kind of seeing those patterns up here in the top area, this will make it a lot easier because all you got to do is remember -2, -2, -2 on everything. Okay? -2 on your subnets, -2 on your host. -2 on your block, sorry, will give you your host. So this makes it, this little chart cheat sheet area makes it very easy to subnet. Okay? Now we've got an exercise for you. And I'm going to throw you a curveball, so get pen and paper. And you will have to subnet this all the way out. And I'll come around and make sure that you're on the way. Blah. Okay. I didn't want to check the microphone. All right, so once again, I'm going to give you a situation, and then you will have to give me all the answers. And you're going to have to subnet it all the way out. Make all the ranges, make all the groups, okay? All right. I need to have subnets that allow me to have 60 computers in each subnet. Does that make sense? I'm not telling you how many subnets I need. I'm telling you that I just need 60 computers in each subnet. That make sense? I need 60 hosts. So, did you draw it out?
1, and then 64,
So, all your answers would be
32, 63. Okay, so if you need 60 computers or 60 hosts, what do you like?
no, that's not in my block. Where are we at? That's right. So, what do you got going on here? Which one is your block out of all of these?
Should be 64.
That's right. So what is 4?
4 is your son.
That's right. So you're going to have 4 groups.
So that's 1, 2.
And that's it. There's nothing more than 255.
Oh.
256. Good job. All right. So, Chris, what did you do first? Benson?
I figured out
The block. Well, first you figured out the host, right? I told you I needed 60 computers in each network.
told me that, so I didn't figure it out.
Okay, well, you had to figure out where to go first. Smart aleck. So you saw the host and you found which one of these can give me 60 computers in each network, and you decided on 64. All right. So 64 would give me how many hosts for my network? 62. So I could technically have 62, which works out perfect because if I need 60 computers, well, I need a router too, so I just put the router up there. 61. So I have 64 here, and that looks like a 9, doesn't it?
Yep.
Not much better, but it's a 64. Now that I've got my block ranged out, you said you found your block, and your block is 64. So what did you do with the block? 0, 64. Boy, it's not getting any prettier. 128. 192. And what do you do when you reach 256? Good job. All right. And then?
Then I found I took 64 minus 1 is 63.
And then?
128 minus 1 is 127.
And then?
192 minus 1 is 191.
And then?
256 minus 1 is 255.
All right. And when you reach 255, you're done. So then what you do after that?
Then I went 0 plus 1 is 1. 64 plus 1 is 65. 128 plus 1 is 129. 192 plus 1 is 193. 63 minus 1 is 62. 127 minus 1 is 126. 191 minus 1 is 190. 255 minus 1 is 254.
So the numbers in the blue are your ranges, but the numbers in the black are your available. And that's the ones that your computers would get. Okay? You with me? Bertha? Chris? No? The numbers in the blue, that is your range. 0 to 63. That is your range. That is your block. But 1 through 62 is the available in that range. I don't know if this is going to help. It's going to make it more cluttered, but there it is right there. Okay? So these are your network IDs. These are your broadcast IPs. And the numbers in the black are what you can use. These are the availables that are good for use. Okay? You got it? Chris? You want to work out another one?
No, yeah, sure.
All right. You got to subnet this one out for me. Okay? You give that look to the board and it makes me worried.
What?
So,
Okay.
what do you have going on here? What do you see? Just, do you notice anything about that?
The 128,
What does that mean?
that
255.255.255 dot.
okay, so we can, oh, it's 1 and then 0, 0, 0, 0?
Correct.
Okay,
You got it from there, right?
yeah.
Okay. So, where are we at?
So that's the primary for this.
Correct.
So now that's your 25,
Here's your cider, okay?
and the remaining portion of that is 7.
Correct.
So
So how many subnets would you have? Here's your subnet mask right here.
So your x1
X equals 1 and y equals 7, yeah. So there's your subnet mask, there's your block, there's your number of subnets, and there's your number of hosts.
I guess I'm stuck.
Okay, so you've got this, good. Let's go back to my chart. Okay. So here's your subnet mask, here's your block. How many subnets would I have?
1, 2, 3, 4.
You're missing the numbers. Look at my chart, because yours has too much writing on it and it's confusing you. Just draw my chart right here.
Okay.
Is it?
just that right.
That's right. Write the titles too of what they are over here, like I have it. Okay, and then what is this right here?
Oh, that's block.
And then what's on top of that?
The
Subnet mask.
255.
No, it starts with 128, 192, 224. Okay.
So you have 128.
So what do you know from this? Do you know the host, the subnet, the block, or the subnet mask? Right here.
Subnet mask.
Subnet mask. So that means there's all your answers right there. How many subnets are you gonna have?
4. Oh, 2.
Where'd you get 4 from? There's all the answers right here. So what is your block size?
It's a 128.
Okay. And how many hosts are you gonna have?
128.
Minus 2 is?
126.
So go ahead and draw out your 2 subnets and draw your ranges.
So
Which one is the most important right here?
the block,
Why is the block most important?
because that's the one that I will tell you.
Okay. So what do you do with your block?
You
Make it a button.
okay. 128, and then 0, and then 128, and then you just
Then hit the button.
okay.
Yeah.
Yesterday is
Okay. Oh. We'll just record this a little bit.
128. Sorry.
Thank you, sir. You should leave it there.
255. Okay. And then you have minus 1 is 126. Oh no, 126 is here. 1 plus 1 is 1. And then 128, 127, 120, 254, 120.
You're right. 129. So you have 2 groups, a group of 0 through 127 and a group of 128 through 255.
Okay.
But your availables are 1 through 126 and 129 through 254.
That's it.
And that's it. All right, so what you got to do is, anytime you have something like this, you got to find out whatever problem they give you, like what do I know? Do I know the number of hosts, the number of subnets, or the subnet mask, or the CIDR. If you knew the CIDR, you could just write in the CIDR number here. For instance, if this was a 25, you have 24 plus 1 is 25. Okay? So in this scenario, you knew 128. Oops. You knew 128. So 128 is my subnet mask, which means all my answers are right here. Okay? So once you get all this, you know you're going to have two subnets, so you could label them out if you want. 1 and 2. Now you also, most importantly, is your block. Is that you know that your block is going to be 128. So what do you do with the 128? You make it a button, you put 0, and then you put 128 under that. And then you keep adding the button. If you add the button, what do you get? 256. And when you get 256, you stop, give yourself a pat in the back, you did a good job. So then after that, you find what's missing, 127 and 255. I've got my two ranges now. There's range 1 and range 2. Now let's find the available. The availables would be 1 through 126 and 129 through 254. Okay? So you've got two groups. The first group is going to have 1 through 126. The second group is going to have 129 through 254. Okay? All right. Now the only way to kind of get this is to practice and to do it a lot. And you can always re-attend the lecture when it comes back around, or re-watch the video, because it's a lot of information. And I have to kind of show you how to do it, the mathematical portion of it. If not, just stick with this way, you know. And then as you go through the courseware, the course is going to teach you how to subnet one way. When you go through the tech lab is going to teach you to subnet in a different way. And then, you know, the book is going to teach you to subnet a different way. So just stick to whichever way that works best for you. Don't try to learn them all. You know, and that's why I go with this route, because with this one you don't need very much math. You know, you just need to know something: the number of hosts, the number of subnets, the block, the increment. The CIDR or the subnet mask. You know any one of those information, you can figure out the rest with this. Okay. So, any questions? No. No? All right. Well, that's it for today.
Thank you.
Thank you.